Okay, welcome back, guys. Today we are going to focus on something new, and it's called factoring by sum and difference of cubes. So you may remember factoring when we did difference of squares. For example, if we had problems like 9x squared minus 25, remember factoring is just reversing the distributive property. And how we would do that problem, we took the square root of 9x squared, which would be 3x. And we took the square root of 25, which was 5. And we did 3x plus 5 times 3x minus 5 would be the factored form. They're conjugates. If we distributed this back out, we would end up getting what we started with. And notice it's two terms. The reason is these are conjugates. If we distributed it back out, the middle terms would cancel out because they're opposites. So when it was squares, we took square roots. So today we're going to be working with cubes. So yes, we're going to be using cube roots. But first, just like with difference of squares, we had to know which numbers were perfect squares. So perfect squares, for example, were 1, 4, 9, 16, 25, 36, so on, just a number squared. Okay, but today we're talking about cubes, so we need to know what the perfect cubes are. So I'm going to make a list here off to the side because we're going to need to use these. So our first perfect cube obviously is 1 because 1 times 1 times 1 is 1. So 1 cubed is 1. Our next one is 2 cubed, which is 2 times 2 times 2, which is 8. Then we have 3 cubed, which is 3 times 3 times 3, which is 27. Then we have 4 cubed, which is 64. 5 cubed, which is 125. 6 cubed, which is 216. 7 cubed, which is 343. 8 cubed, which is 512. 9 cubed, which is 729. And 10 cubed, which is 1,000. Okay, so you should know at least up to 10. You wouldn't be expected to know more than that, and you would have a calculator, so you really don't have to have them memorized, but it's good to know them. Okay, so unlike the difference of squares, there is some memorization that goes with sum and difference of cubes. So notice, first of all, it's sum and difference. So when we had squares, when it was like this, we could factor it because it was difference of squares. When we had the sum of squares, this was what we called prime or not factorable, because if we tried to factor this, there's no way we could get two binomials that'll multiply back to this. It was not factorable. But notice with cubes, it's allowed to be addition or subtraction. It's sum and difference. So anytime you see sum and difference of two perfect cubes, what you're going to do is you're going to use this. So first of all, make sure you write down these formulas. You have a binomial times a trinomial when you have sum or difference of cubes. So it goes as follows. So when you have a cubed, the first thing you do is you take the cube root of that. So the formula is a here, and then the cube root of b cubed would be b. So you need to remember that the formula starts with a and b in the first binomial. Then it goes a squared, a times b, and then b squared. Notice I'm not writing any signs in yet. You don't want to fill those in until we talk about the next part. So how you're going to memorize the signs is you're going to remember SOAP. And SOAP is an acronym for same, opposite, always, positive. Not really sure why I wrote it vertical like this, but you get the point. Same, opposite, always, positive. What does that mean? So that's the way you remember what the signs are when you factor it. So if you start with addition, what you do is you use the same sign here, opposite, always positive. Then when you have subtraction, use the same sign, which is subtraction, opposite of subtraction, which is addition, and then always positive. The last one's always plus. So that's how you're going to remember the signs here. Soap. Same, opposite, always positive. Okay, so now I'm going to actually factor these right here. So if I take a look at number 1 here, I notice it is the sum of 2 perfect cubes. What I mean by that is there's a number that I can multiply by itself 3 times to get 343, and there's a variable I can multiply by itself 3 times to get y cubed. So step number 1, take the cube root of y cubed. So what times what times what is y cubed? It would be y. And what times what times what is 343? So it would be 7. And we notice 343 is on our perfect cube list, so we know that's a perfect cube. Okay, so I'm going to say that A is y and B is 7. Why I'm saying that is because that'll help us to substitute those numbers into our formula. So we know we have addition. So when we factor this, we always have a binomial times a trinomial. Same sign. Well, what was the original sign in the problem? It was addition, so the same sign will be plus. Opposite sign is subtraction, always positive. So I like to write the signs in before I actually put A, B, any of that. Okay, and now it's pretty easy if you know the formula. You just input what you have. Whatever A is goes here. Oops. And then whatever B is goes here. So that's 7. And then the next spot is A squared. So A was y. Y squared is y squared. And then the next one, we said it was A times B in the formula. Well, whoops, sorry. A is y, B is 7, so y times 7 would be 7y. And then my last one is B squared. Well, B is 7, so 7 squared is 49. And that's it. You don't have to worry about in the sum and difference of cubes problems that we will do about factoring more with this trinomial. It's very rare that you'd ever have to factor that trinomial again. Okay, so moving on to the next one here. So we see again we have perfect cubes. 8x cubed is a perfect cube because there's something times something times something. That'll be 8x cubed. And same thing with 27. We see it's subtraction. It doesn't matter with cubes if it's addition or subtraction. So first thing we do is we take the cube root of 8x cubed. So what times what is 8x cubed? It would be 2x, because 2x times 2x times 2x is 8x cubed. Okay, and then we take the cube root of 27, which would be 3, because 3 times 3 times 3 is 27. So A is 2x, B is 3. Okay, and now we use our formula here. Okay, so the first thing we do, we put our signs in, sorry. So it follows SOAP. So same sign as the original problem, opposite sign, and the last one is always positive. And that's coming from the original problem right here. Okay, and now we plug in A. A goes here. B goes here. Then it's A squared. So 2x times 2x is 4x squared. Then it's A times B. A times B would be 6x. And then it's B squared, which would be 3 times 3, 9. There we go. Okay, so moving on to the next one here. Take a look again. I see perfect cubes. Okay, so cube root of the first one So what times what is a cubed? It would be a. And what times what is 1000b cubed? It would be 10b. So a is a in this case, and b is 10b. A little confusing if you want to say x, or your first one's a and your second one's 10b, to not get confused on that. That's fine. But remember, you're just using these right here in the formula. Okay, so let's draw out our binomial times our trinomial. Okay, and then same sign, so it's addition, because the original problem was addition. Opposite sign, so that would be subtraction, and then the last one's always plus. Okay, so our first one is always a, whatever a is. Our second one is always whatever b is, which is 10b in this case. Then we have a squared, since a is actually a in this problem, it's a squared. Then we have a times b, so a times 10b would be 10ab. And then we have 10b squared, which would be 100b squared. Okay, so if you're starting to get this, if you want to go ahead and then just use the video to check your answers, that's perfectly fine. I'm just going to keep going right along with this. So if we take a look here at number 4 is just a little bit different because you'll notice there's a GCF. So still, just like all the other types of factoring here, you always have to check for a GCF before you do anything. So what is the greatest common factor here? The only thing they have in common is y. So we're going to take out a y from each. So when we divide each term by y, we get x to the third plus 125. Well, if this is a GCF problem, why is it in the section of sum and difference of cubes? Well, if you look at the problem now, we have our perfect cubes. We have x to the third, and we have 125. So what's the cube root of x to the third? It would be x. What's the cube root of 125? 5. So if we do our factoring here, same sign, so same, opposite, always positive. And then we do our substitution. It always goes whatever a is, whatever b is. A squared, a times b, b squared. Honestly, that just takes a lot of repetition of doing it, and then you'll be able to remember that formula. But since we took out a y as our GCF at the beginning here, don't forget y needs to be in front. So if you want to put that in the front right at the beginning, just to remind yourself, that's always a good reminder right there. Okay, so now I'm going to do number 5. Again, this is similar. It has a GCF also. So the GCF here is, so if we take a look at this, is there a number that goes into 56 and 7? Yes, 7. Do they have any variables in common? Yes. Take the one with the smaller exponent, so x. So if we divide each term by 7x, we get 8x to the 6th minus y to the 6th. Okay, well, we're not done factoring because we see perfect cube, perfect cube. So what is the cube root here of 8x to the 6th power? So what times what is 8x to the 6th? Well, that would be 2x squared, because 2x squared times 2x squared times 2x squared is 8x to the 6th. Remember, when you're multiplying, you add your exponents. And what is the cube root of y to the 6th? That would be y squared, because y squared times y squared times y squared be y to the 6th, because you add up all the exponents. 2 plus 2 plus 2 is 6. Okay, and now it's just substituting it into our formula. We always have binomial times a trinomial. Same sign, the original sign of the problem was subtraction. Opposites, always positive. A here is 2x squared. B is y squared. 2x squared squared would be 2x squared times 2x squared would be 4x to the 4th. Then if we multiply a times b, we have 2x squared, y squared. Sorry, I didn't leave enough room. positive. Okay, and then we square our b terms, so y squared would be y to the fourth. Y squared times y squared is y to the fourth. And what's missing? The original GCF. So the original GCF, don't forget, was 7x, so that must go out for it. Okay, so now a few more. If we take a look at number 6, it has a fraction, but again, it's really no different here. So you're taking a look at it. Does it have a GCF? It does not look like it. Okay, so we see they're both perfect cubes, so let's take the cube roots. So what times what is 1 over 8? If it's easier to think about it like this. What times what is 8? That would be 2. But since we need it to be 1 over 8, it's just 1 over 2. 1/2 times 1/2 times 1/2 is 1/8. Okay, and then b would be 2x, because 2x times 2x times 2x is 8x cubed. Okay, so now it's just a matter of substituting. So SOAP, same, opposite, always positive. A is 1/2, b is 2x. A squared would be 1/4. 1/2 times 2x would be 1x. And 2x quantity squared, 2x times 2x would be 4x squared. There we go. Okay, and number 7, again, here we have a GCF. So if we take out our GCF, what do we have in common here? So 343 and 216, I don't think those have anything in common, and if they do, we could always take it out at the end. But right away, we see they have an x in common, so let's take that out. Okay, so now, if we take the cube roots of both, what times what is 216? It's 6. And you'll get better at cube roots the more that you do them. So what's the cube root of 343? It's 7. What times what is x to the third? The easiest way is just divide those exponents by 3. X to the third divided by 3 is x to the first. Y to the 9th, 9 divided by 3 is 3. Okay, now let's fill in our signs. So same sign as subtraction, opposite is addition, always positive. A is 6, B is 7x, y cubed. Okay, a squared would be 36. And then a times b would be 42xy cubed. And then b squared, so 7 times 7 is 49. And then x times x is x squared. Y to the third times y to the third is y to the 6th. And then don't forget, we took out a GCF of x at the beginning, so we need to put that x out front. And honestly, this is really as hard as these ones get when they have the GCF. Okay, just 2 more practice ones. So take out your GCF first, if there is one. So how many x's they have in common? 2 each, and 6 y's. So when we divide each term by that, we get 1 minus 125 x to the 6th, y to the 6th. Remember, exponent properties, when you're dividing, you subtract exponents of the same base. Okay, so now if we move along with factoring this, we know it's a binomial times a trinomial. Same sign, opposite, always positive. And the cube root of our first one was 1, so a was 1. And then the cube root of our second term was 5, because 5 times 5 times 5 is 125. And then just divide your exponents by 3. 6 divided by 3 is 2. 6 divided by 3 is 2. And now we can plug them in. So don't forget to get a and b first, before you substitute it in. I've seen people in the past just plug in what they have from the original problem. Make sure you take the cube roots first. So a and b. Okay, and then a squared is 1 squared, which is 1 times 1. And then a times b is 5, x squared, y squared. Probably should have left more room. And then b squared would be 25, x to the 4th, y to the 4th. And then don't forget, we took out a GCF at the beginning, so that goes out front. Okay, and then last problem right here. So, GCF. Well, they're both even numbers, so they have to have 2 in common. So 2 is going to be the largest number that goes into 2. And then if we look, do they have any variables? Yes, they have a b. They both don't have x's. They both don't have y's, so that's it. So GCF here. And then divide by 2. So 64 x to the 3rd. The b's canceled. Minus y to the 3rd. Cancel, cancel. Perfect. So what's the cube root of 64? That'd be 4. X to the 3rd, just divide that by 3. And then y to the 3rd divided by 3 would just be y. So b is y. So now let's draw it out here. We have a binomial times a trinomial. It's always the same sign as the original problem, opposite, always positive. Okay, a and b. A squared, so 4x to the 3rd times 4x to the 3rd, multiply 4 times 4, add my exponents. 3 and 3 is 6. Okay, and then multiply a times b. 4x cubed y. And then b squared would be y squared. And then we took out a GCF, so don't forget that 2b should go in front. And that is completely factored form there. Okay, so hopefully this helps you guys to complete these notes. Let me know if you have any questions. And then the next assignment for this week will just be